Trust the process. Now this Friday, what do you have? A quiz. The quiz is going to cover everything. Anything you've learned in this class, from up here to back there, is fair game. So please, for the love of humanity, start studying and working the stuff now. If you have not signed up on Remind, you should have done that forever and a day ago. You need to sign up on Remind so you're getting these video links and stuff that I'm sending you. Okay? So the whole lab that you started on Friday and you finished yesterday is all focusing in on accuracy and precision. So we see these two, they kind of get looped together, and everybody just wants to look and say, this is this. They're both together, hand in hand. They're totally separate ideas. Something can be completely accurate, but not precise. Something can be precise, but not accurate. So let's say, for example, I have two targets. There's bullseye. And for simplicity, we're trying to hit the bullseye. So you have two separate things you're looking at. So let's say, for example, on this first target, I'm shooting and I end up hitting here. Here, here. But then I change whatever I'm shooting with. Let's say gun for simplicity. And I'm here. So I'm aiming here, but I hit here, here, and here. This is the best example I can give you to explain the two differences. Accuracy is all about the same thing, time and time again. That person is accurate. That is looking at grouping. Do I have anybody that shoots archery in here? Okay, whenever you're shooting archery, what's important? You're hitting the bullseye or it's a tight group. Because if it's a tight group, you just got to move the sights. It'll line it up to where you're hitting the bullseye. That's the difference between accuracy and precision. This is hitting the bullseye, but it's spread out. That's accurate. That's precise, sorry. It's spread out, but it's hitting the bullseye. Precise, precision. You're slamming right on target. Accuracy is tight grouping. This is accuracy. Am I precise? No, not even close. I'm trying to hit here, but I'm hitting up here. But is this okay? Yeah, because that's accuracy. Back in the lab, what did you find was the most precise instrument, precise glassware? Yes, I am waiting. Precision is you hit the mark. It was supposed to be, I said the volume was 10 milliliters. I hit 10 grams.
Graduated cylinder?
Graduated cylinder can be one. What'd you get?
Like that was right on the money. It was 10 milliliters.
iPad was right on the money. Now this is the thing, is you guys can get different results in different trials. Y'all don't judge me. Yes, I keep my markers in a first aid kit. Any teacher comes in here trying to steal them, I have no idea where to look. Unless y'all rat. The most precise should have been the pipette. This is the way you can tell. You could have got the most precise with the graduated cylinder, Why? Because they can be very accurate and very precise. But here's the thing. You guys are not great technique-wise, so use your observations to the best of your ability. How many measurements can a graduated cylinder make? A whole bunch, right? How many measurements can a pipette make? One. So it is the bomb.com when it comes to it. So the most precise will be your pipette. What did you see as the second most precise?
The burette.
Burette. Now, I will be honest with you. This is where you kind of can see some trading back and forth. Some of you guys probably got graduated cylinder. Some of you probably got the burette. I'm going to be honest with you. Okay? You guys really struggle at making accurate measurements. The measurements you're looking at, where do you measure with the meniscus? The bottom of the meniscus. I watched people in first and in eighth measuring top. And then the bad thing happened is you measured the top, and then when it got down, you measured the bottom. And that's going to throw your results all out of whack because you changed your measuring points. You can't do that. Please do me a favor. Do not think that I'm like slamming you today. I'm trying to make you aware of things that we need to improve on. Third, graduated cylinder. Now fourth and fifth can go either way. It could have been the beaker or it could have been the Erlenmeyer flask. So fourth is a tie for the flask or the beaker. The flask and the beaker are not meant to make measurements. They're meant to hold liquids, for me to pour the liquids out. They're meant for me to mix things in. Every piece of glassware you deal with has a specific purpose. I'm going to look at you and tell you, the pipette is not going away. You have a lab that will be coming up. We are going to literally test the concentration of sugar within soft drinks. So we're actually going to do a lab and figure out which soft drinks out of the ones you vote for are the worst for you. It's just full of sugar and you just should not be consuming. Everybody understand the difference in accuracy and precision? I don't got to give you a big, cute definition, do I? Everybody is blah today. I want you to smack yourself a couple times in the face, wake yourself up. Yo, let's go. Why is everybody like you drank a whole bottle of NyQuil this morning? You're killing. I can hear a pin dropping here.
Any other teacher would love to hear a pin drop. You might be the only one over here complaining that we're quiet.
I do that because it's like the look I'm getting is like this, like, and I feel like I'm talking to you, but there is nothing coming in. Nothing's entering and nothing's staying. It's just, Okay. I want to talk about some things from the lab as well, hitting some stuff up. Because a lot of you guys have struggled with this. And yet again, I'm not holding anything against you. I'm not assuming anything when you walk in this room. But I want to make sure I have to get you to where you can think on your own. Especially because here in a couple of weeks, you're going to want to be able to think on your own. It's very important. I'm going to make you think on your own. Whenever you're trying to get the mass of something, you have multiple different ways you can do it. And a lot of people were struggling with this yesterday, not only in here, but in 8th period as well. We struggled with the idea that we're trying to get the mass of water. So you have a couple options you can do. Hopefully I can just talk with you and you get this. But let's say First, I'm trying to get the mass of water, but I have to hold it in something. So I need a difference between the two. So the first thing I'm going to do is get the mass of beaker. What is the point of getting the mass of the beaker? Getting the mass of the beaker literally tells me how much to subtract. Why? I'm getting ready to put some water in it, and I'm trying to find the mass of the water. So I'm going to get the mass of the beaker and the mass of the water. If I subtract the mass of the beaker, what am I left with?
The mass of the water.
There we go. Y'all get awake a little bit. So number 2, we choose volume of water. Why did we choose the volume of water? Because whenever you look at the density of water is 1 gram per milliliter. So for every milliliter, I have a gram. They're interchangeable. You remember how cubic centimeters is equal to milliliters? Y'all better remember that, I'm just telling you. This is the same thing, they're interchangeable. So whatever volume of water I chose, I should get the same mass. So volume of water equal mass of water. For those of you that are freaking out, the units will change.
Come to the office.
It's the difference in a gram or a milliliter. If we're talking volume, we're talking milliliter. If we're talking mass, we're talking grams. Got it? Because units matter. So we chose the volume of the water so that we can figure out the mass we're supposed to have. So that 3, when you get to step 3, you get mass of beaker plus water. The reason we did that, subtract beaker mass to get water mass. Anybody got a question? I'm taking it a little slow because I know you guys are kind of struggle busting. Look, I want to see, don't you? Alright, so you now have the mass of water, which is what we're trying to achieve. But here's the big one, and I left this on here. You guys get to keep this. You're going to get points that you did this. You get to keep this. Because you need to know how to make a percent error calculation. I put it on there for you. I also put on there how to get the mass of the water. Mass of glassware with water minus mass of glassware before water. Equal mass of water. Your percent error calculation is dependent on 2 pieces of information, the approximate measurement and the actual measurement. The approximate measurement will be what one?
Volume of H2O.
It's going to be the volume.
I was guessing. I was not, I knew that. Woke up and knew that.
Why volume of H2O?
Because that's approximate.
Because of this identity. I chose 20 milliliters. How much water should I get?
20 grams.
20 grams. That's why that is the approximate. Which one is the actual?
The mass of H2O.
The mass of the H2O. This one down here that we can get. Subtract it out. Get it. This right here is the actual. So what we do is we will use these two pieces of information to make the calculations. So let's say, for example, you did the lab. Somebody choose me a piece of glassware.
Erlenmeyer flask.
Okay, we did Erlenmeyer flask. We got the mass of the Erlenmeyer flask. I'm going to get a calculator before I jack this up. I'm pulling this out of my head. We got the mass. I ain't gonna do that. Let's say we got the mass of the Erlenmeyer flask, which in this case is not going to be beaker, it's the Erlenmeyer flask.
Who's Erlenmeyer?
I guess the guy that created it.
I asked for that one, didn't I?
You did. So, mass of Erlenmeyer flask, let's say we got 142.3 grams.
Donnie Fortner to the office, please.
Now we have to choose a volume of water, so you choose me a volume.
8,
Let's choose something that actually be on that level.
30, 40, 30. He said 20 and 40. You skipped 30 on purpose.
Alright, we chose 30 milliliters. What's that mean?
You said
30 grams. That's the what mass?
the mass of the water.
Mass of the water, but what mass of the water?
Approximate.
The approximate mass of the water. Everybody getting it? So then, let's slide down. Let's get here. Let's say for step 3, you got the mass of the Erlenmeyer flask and water, and we got it to be 174.4 grams. So, is that the mass of the water? Why is it not the mass of the water?
Is it both in the beaker?
Because it has the beaker mass, or in this case, that Erlenmeyer flask. So what do we got to do to get the mass of the water?
Subtract.
Subtract what?
142.3.
Why 142.3?
Because that's the mass of the beaker.
It's the mass of the beaker or the mass of the flask?
I mean flask.
So subtract that out. I'm going to do it for you. You're going to get 32.1 grams. What is that? The actual mass of the water, my scalp. So that's grams of H2O. This right here is my actual measurement. I performed a lab, that's what I got. So, on that lab handout I gave you, you look at it. The percent error of this trial is equal to the approximate measurement, which is what? 30 grams. You're going to take the absolute value of this top thing too. I didn't put that on there. Take the absolute value so you don't end up with that negative number. 30 grams minus which measurement?
The 170 oh, the 32.1.
Actual measurement, which is the 32.1 grams into absolute value. We will divide that by what's on the paper?
32.1 grams.
the actual measurement is 32.1 grams. You're really getting awake now. And we'll multiply that by 100 so we have a percentage. When you do this, I get a 6.5421% error.
You think you like 4 decimal places?
I like 4 decimal places asked. I'm not going to hold that against you on the first couple of quizzes because you got to get used to it. Is that a good percent error?
Not terrible.
Yes.
Let's be honest. For me,
Horrible.
that's awful. Which also, I would never use an Erlenmeyer flask to get 30 milliliters of water. For you all, if you gave me this, I would be ecstatic. Especially watching y'all in lab. I'd be like, I don't know how'd that happen? That's fine. Here's the important thing. I don't expect you to go back there and get a 0% error right now. What do I expect you to be able to do? To understand, if Mr. Hall worked out and gave you a word problem, working you through this, then I went back there, and I went back and I was trying to find the accuracy and precision of an Erlenmeyer flask. So I got the mass of my Erlenmeyer flask, and it was 142.3 grams. I chose 30 milliliters as my volume of water. So I put 30 milliliters of water.
Miss Michelle Cooks and Miss Teresa Hicks's classes will report to the gym today.
So I put 30 milliliters of water in my Erlenmeyer flask and got the mass of the Erlenmeyer flask and water to be 174.4 grams. What is the percent error of this trial?
6.5421.
But here's the thing. I need you to be able to work through it. Okay? So right now, everybody's giving me like a NyQuil dazed. I'm a brainless zombie. I'm out of here. I'm sitting in your class physically, but mentally, I'm still in the bed. Kind of look right now. And I need to make sure you got all this and you understand it. So if you ain't got it, now's the time for a question.
Throw it down.
Everybody got it?
I think so.
This is what you were doing, because this is what I've introduced you to now. You now know how to get a mass of something in the lab. Yes?
Can I get a tissue?
Absolutely. Here, we should pass it back. Woo! You now know how to get a mass of something in the lab. You now know what your glassware is that you're going to be using in the lab. You now know if you need an accurate and a precise measurement, which piece of glassware you're going to use. You also know pieces of equipment that are in the lab. You don't know them all, but you're learning them. The pipette. They suck. So no questions? Perfect.
Mr. Hall.
Yes?
I felt it was the best to use.
I think I need to turn myself against the authorities.
Why?
I killed Tony this morning.
That's awful.
And you know what I done
I
Friday?
can't sleep tonight.
You know what I done Friday morning? I killed him.
He's cute.
They keep jumping out in front of me and my car's low to the ground.
And you don't know how to slow down?
Well, when you're going like 80 down my hall.
Where are you going at?
When you go like 80 and then they're like
Bring yourself
just
in
sit
for a
there
drive.
and then they jump out in front of you, you can't stop on a dime, so
Wow.
Well, you shouldn't be going 80 down the holler.
All right.
Yourself in for
I
that.
like this goal.
So let's get some real deal chemistry. Okay? So I got this question. What is matter made of? I'll wait for an answer because I got a feeling someone in this room's got it.
Atoms.
Thank you.
That's what I was
Oh,
going
really?
Yeah,
Oh, I knew that. I woke up and knew that.
I'm like all night.
can't wait for Friday. Atoms. This is the basic building block of matter. Everything is made of atoms. Everything we study and we look at is an interaction of atoms. So now I have another question. What is atoms made of?
Molecule?
Subatomic particles.
No, atoms make molecules.
Atoms make molecules. Atoms are made of
Elements?
3 subatomic particles.
Protons, neutrons, electrons.
Well, we can tell the NyQuil is worn off of Dalton.
More like Adderall right now.
Yeah.
So let's talk about the 3 subatomic particles.
What's subatom?
Really, really small. Smaller than atomic. So small that if you want to look at it and even have an idea of what's going on, you have to use an electron microscope. So, hopefully you have got to know your subatomic particles before. But yet again, I'm not holding you responsible of knowing anything in this class. Because let's be honest, some of you probably haven't heard of subatomic particles. That's okay. I'm not upset with you. But I want to talk about them. They're crucially important to us. The first one we're going to talk about is the proton. Now, before, like I told you guys, I'm not going to expect you to give me this straight up definition like other people would of a proton. All the proton is the positively charged subatomic particle found in the nucleus of the atom. Is that Google's definition? No, that's Mr. Hall's definition. If you want Google's, look it up. So that is the first subatomic particle that we're going to look at and we're really going to focus in on. The second one is the neutron. Neutron. Neutral. So, neutral charge. Well, I don't even want to put the word charge. Just neutral subatomic particle. Neutral subatomic particle means no charge found in the nucleus of the atom. Number 3, the electron. The electron is a negatively charged subatomic particle found on the outside of the atom. Here's the way I remember it. Proton starts with P. Positive starts with P. Neutron and neutral. Electron, electricity is the flow of electrons, and if you get shocked, it don't feel good, so it's negative. I don't know how you're going to remember it, but you best remember it. So when you're looking at these, they all have abbreviations. The proton is abbreviated. Little p plus. The neutron is N with a little 0. The electron is a nice little E with a negative sign. This is how you will see me This is how you will see me showing them now. Protons are positively charged. Every proton has a +1 charge. Neutrons are neutral. Electrons have a -1 charge. Questions? Okay. I have a gift for you. It's the first of many to come. Oh boy. You will enjoy it. It is a handout.
What's the first study guide? That'd be real good.
Yeah.
Oh, I got you one. It's called your notes.
Oh, yeah, we just love that. I wish I could, I can't read. I don't know how to read.
You should drop this class in.
I should drop all my classes in.
Singing the periodic table song.
What's that song you said, you know, the ABCs, yeah. I know what I'm talking about.
Okay. So, what I've given you is the periodic table. I've given it to you for a reason. On the periodic table, you're going to see a lot of information. I want to make sure you know what you're looking at. You have to be able to break this apart and know what you're seeing. So on my periodic table, that's the same one that's on my view board is the same one that I just gave you. There's many reasons why I gave you that one. We'll discuss it throughout the class. So every one of these are placed in a box. And you're going to see in these boxes will always be certain pieces of information. Now I'm going to give you the ones, the certain pieces of information that are always on a periodic table. So the first one, which can be flipped around, but on ours, the element's name is at the top. This is just the element's name. It tells you its name. It's like if you looked at me and I had a shirt on that said Kevin, it would say my name. After the element's name, you can flip it around and get different things, but you get this number. This is the atomic. I need to do a different color. Hold on, I'm going to get everything all mixed up. Let me change that color. I'm going to do orange, because I just haven't used orange today. You have the atomic number. The atomic number is the number of protons. I will also stress this to you. I will always give you a periodic table on every quiz you take except for one. The one I will not give it to you is the element quiz because that'd be giving you the answers. That's a dumb move on my part.
Like, so we have to know all these when you go get the quiz on?
You're not going to have to know them all.
That'd be fun.
Next,
Yeah.
you will see a symbol. So I'm going to put an X for symbol. This is 1/2 letters to symbolize abbreviate the element. The important thing is, first letter, always capitalized. Always has to be in cap. Second letter, always lowercase. You always see it this way. First letter is always capital, second letter is always lowercase. Now, there's another piece of information on there. They call this the average mass. We're not going to get into it today, but we're going to. Average mass. We will pick up here tomorrow. Please have a wonderful, fantastic day. Yes, dog.
How come there's no way to